Rahi and I'm part of the Oracle Cloud Infrastructure team. In this module, we'll look through the various gateways provided by the OCI Virtual Cloud Network Service. But before we get into any of the gateways discussion, we need to understand the concept of route tables. You saw this earlier in the demo when we were talking and introducing Virtual Cloud Network. We did create use route table in the VCN service when we were using the console. But let's talk about what a route table is. A route table contains rules about how IP packets can travel to different IP addresses out of the VCN. So right here you can see there is a route table which is attached to the subnet. Now what does the route table consist of? It consists of a set of route rules. Each rule specifies destination CIDR block, and it specifies the route target, the next hop for the traffic that matches that CIDR. So what exactly do we mean? So if you look at this particular subnet, it's a public subnet. It can be regional or it can be AD specific. In this case, I'm just using a regional public subnet. And in the route table, there is an entry which says 0.0.0.0/0, which means any IP address or all IP addresses. So this is my destination CIDR, packets destined for any IP address. They need to go to Internet Gateway, and this is what is being shown here, all traffic destined for Internet Gateway. So what I do is I create an Internet Gateway. It's a managed service provided by the OCI Virtual Cloud Network Service, and right here you can see, because of that particular entry in my route table, my packets can actually go to the internet, and they can also come from the internet. So somebody could actually access, if it's a web server, they could access my web server running in the public subnet. Now, important considerations to keep in mind: each subnet uses a single route table. So it can only be each subnet can only have a single route table. You can specify that when you are creating the subnet, or you can edit it later if you are not sure what kind of route table to use. You could edit that later. Route table is used only if the destination IP address is not within the VCN's CIDR block. So what that means is you don't require any route rules in order to enable traffic within the VCN itself. So as you can see here in this particular graphic, there is no rule like a local rule required here for routing traffic within the VCN itself. It's actually done implicitly. You really don't need to write a rule like that. When you add a gateway, whether it's an internet gateway, NAT gateway, different kinds of gateways, you have to update the route table for the subnets that uses these gateways. Otherwise, you can create a gateway, but the packets will black hole. They have no way to go to the gateway. Then it seems pretty logical, but that's how the route table works. So having talked about looked at route tables briefly, let's talk about the different gateways which are supported in the OCI VCN service. The first gateway is called Internet Gateway, and as the name specifies, it's a gateway which takes traffic in and out from a public subnet. So as you can see here, as we had seen in the previous slides, we have a public subnet here, can be regional or AD specific, and there's an instance which has a public IP. Now it can be a web server or a load balancer or something. You are running your own load balancer, those use cases, but it has a public IP. And of course, if it's a web server, we want users to access it, or if it's a load balancer, we want users to access it. So we create this thing called Internet Gateway. It's a managed service, so you really don't need to care about the bandwidth or HA. All those are taken care by Oracle. You create this Internet Gateway, and then using that gateway, the packets can go in and out to this instance in the public subnet. Now, important things to keep in mind: you can only have one internet gateway for a VCN. So it means that if you have different public subnets, Let's say you have a public subnet where you are hosting your bastion servers, and you have one for web servers, one for something else. All of that traffic goes through, and all of them subnets are part of your single VCN. All of them go through the one internet gateway which is available for the VCN. As we saw in the previous slide, if you, after creating an internet gateway, you need to add a rule in the VCN's route table which says that packets to 0.0.0.0/0, meaning all IP addresses, every IP address need to go to the internet gateway. And if you do create an internet gateway, add a rule, you have a web server, then you can start communicating to that web server. So that's the first use case, where you have let's say a web server or a load balancer, and you need to access it through the internet. Now there's another use case where if you have an instance in a private subnet that does not allow traffic from the internet to reach it, then there is no way for IP packets to reach the internet. We need a mechanism for sending those packets out. So for example, you have a database and you need to get some patches, and then also route the replies correctly. This is, in networking lingo, it's called network address translation. In OCI, we do this through a managed service called NAT Gateway. A NAT Gateway accepts any IP packets bound for the internet coming from the private subnets, send those packets onto their destination, and then sends the returning packets back to the source. So let's see how it works. So similar example setup as before, but now instead of a public subnet, we have a private subnet here, right? So this can be hosting your database, for example, and the database needs to be constantly, regularly patched and updated, right, to get patches from the internet. Now because it's a private subnet, as we just said, there is no way for packets to go to the internet and get the response back, right? Because it's a private subnet, you're not using an internet gateway, you cannot reach internet. So you have this managed service called NAT Gateway, which gives this whole private subnet access to the internet without assigning any public IP. So this is all private IP. You really don't need a public IP. You don't need an internet gateway. So what this means is host can initiate outbound connections, and of course those packets will come back, but not receive inbound connections. So meaning, if I'm an actor here, I want to ping my database server, I cannot do that. NAT Gateway would block those responses. And again, it's a managed service, so we take care of things like HA, things like bandwidth. So you really don't have to manage those yourself. And as we have been seeing in the previous slides, the rules here in the route table, it's basically saying all the packets destined for any IP address should go through NAT Gateway. So basically, you are sending all the traffic from this private subnet to the NAT Gateway, and then if you are getting patches or updates or something, those packets are coming back, and that all is managed by the NAT Gateway. Now, important thing to keep in mind, you can have more than one NAT gateway on a VCN, though a given subnet can route traffic to only a single NAT gateway. So this is a little different than the internet gateway. The third use case is around this concept called service gateway. Now, what exactly do we mean by that? Let's say like in the previous example, you have a database server which is running here in a private subnet. So this is again a DB. It's running in a private subnet. But now, instead of getting the patches, what you want to do is you want to do a backup. And the best place to do a backup for, let's say, a database is object storage. But now the object storage service is a public service, has a public endpoint. Now, from this instance, you cannot reach the object storage because you would need a public IP address. So typically many customers use is they assign a public IP here, and then they can access the object storage. Now that's not a secure design, right? You should never have a public IP assigned to a database server. So how do you go about doing the backup, still leveraging the benefits of the object storage, right? So what you do is you create this managed service called service gateway. Again, we take care of HA, again we take care of bandwidth, so you don't have to worry about those. And using the service gateway, any traffic from the VCN that is destined for any of the supported OCI public service, it uses the instance private IP address. You don't need a public IP, so it uses the private IP address for routing. The traffic goes over OCI internal network fabric. It never traverses the internet, even though you are accessing the public services, the public OCI services. So it's a very secure design, and you can still leverage all the benefits of public services. Now, how does this work? Similar to the previous examples, you have a route table here. Now, instead of giving a specific CIDR block here, you provide a service CIDR label. So there are two kinds of label which are available today. For example, if you are going to object storage, you could specify object storage is a regional service, so you could specify OCI region object storage here, or you could specify all services. So in this case, in future, if you have other services you want to access, you could actually do that, because you have access to all the OCI services through going through your service gateway. The last design pattern is around use cases where you have a private subnet here, might be a database, but now instead of going to the internet, you are going to your own customer data centers. So this can be for let's say you have your DNS running on-prem, right, and you want to access that through your database running in the cloud wants to access it, or you have your on-prem environments from where you want to migrate data, right, so you need to connect to that. So for those use cases, we have again a managed service called our dynamic routing gateway. It's a virtual router that provides a path for private traffic between the VCN and destinations other than the internet. So you're not going to internet, so you're not using internet gateway or NAT gateway, or for that matter service gateway, going to a public OCI service, but you are going to your on-prem environments. So in this case, you can use the dynamic routing gateway to establish a connection, and there are two different mechanisms for doing that. One is through using site-to-site VPN, and the second is a dedicated private connectivity called Fast Connect. We'll cover these in subsequent modules on connectivity. But as the graphic is showing here, through the DRG, now your database can communicate to your on-prem environments. Now, this is we have been seeing this earlier. You create the DRG, you attach it to the VCN. You have to add a rule here, right? And the rule is very similar to what we had been discussing earlier. All the traffics, so all the packets destined for any IP address has to go through DRG for this particular subnet, right? So you're basically sending all the traffic through the DRG here. Now the DRG is a little bit different than the other gateways we have looked at until now. DRG is a standalone object. You must attach it to a VCN after you create the DRG, and VCN and DRG have a one-to-one relationship, meaning a single VCN can only have one DRG, and one DRG can be attached to a single VCN at a time. So just let's quickly summarize all the network connectivity options we saw in this module. So the first one is around letting instances connect to the internet and receive connections from it, right? Bidirectional going to internet. So you would use internet gateway. If you want instances to reach the internet and of course get those packets back for things like updates, but not have inbound connections initiated from the internet, you have NAT gateway. And the network address basically is doing the network address translation. If you want the VCN, your host in the VCN to privately connect to OCI public services, for example object storage, but you are bypassing the internet, traffic is all going through Oracle's network backbone, you would use service gateway. And then finally, if you want your host, your VCN to connect to your on-prem environment, again for private traffic, you could use something like a dynamic routing gateway. So these are the four gateways with different distinct design patterns. In the next module, we'll look at a couple of these demos where we create an internet gateway, we create a NAT gateway, and then subsequently we'll also talk about peering and transit routing, which completes the set of all the network connectivity options available with OCI virtual network service. Thanks for watching this lecture. If you have time, please join the next lecture where we do a couple of demos on these gateways. Thank you. Hi everyone, welcome to this demo on running a web server